So hello, my name is Marcus Wiley, and this is my presentation over cystic fibrosis. Today I'm going to be covering what cystic fibrosis is, what are the causes of cystic fibrosis, how does it affect the body, how does it work at a molecular level, and when is the disease noticed and how it's diagnosed. The first big question here is, what exactly is cystic fibrosis? The answer is actually a little bit more complicated than just calling it a disease. To really first get into what cystic fibrosis is, you got to understand what does cystic fibrosis really affect. Cystic fibrosis affects the transportation protein CFTR, or the cystic fibrosis transmembrane conductance regulatory. This is a protein channel within the cell that pumps out chlorine ions out of the cell itself. If the CFTR is working correctly, it plays a vital and crucial role in keeping the balance within the cell in between salt and water, in between chloride and water in the bodies. With that said, what cystic fibrosis is a genetic disorder that causes a mutation of the cystic fibrosis transmembrane conductive regulatory gene. This mutation doesn't allow it to properly pass through the chloride ions. That was my mistake. Okay. What causes cystic fibrosis, or CF? Just as a quick shorthand to help with this, is a mutation, actually. The cystic fibrosis stems from a mutation of the CFTR gene. This gene is located on chromosome number 7, and it is an autorecessive mutation. That means that it can only be contracted if both parents are a carrier of the mutation on the chromosome. If you look at my little picture here, you see a strand of chromosome 7, and it's highlighting the mutation of the CFTR protein. I've explained to you what it is. Now let me show you how it works exactly. What cystic fibrosis does is stop the CFTR protein from functioning properly. That means because the blueprints for it have been altered or damaged. If you were to think of it like a contractor, the genes are the blueprints, the map of how to build something. What cystic fibrosis essentially does is alter, change, or destroy those blueprints. So when the body cell goes to truly build it, there's nothing for it to build, or it builds it incorrectly. Without a proper working chloride build, the cells are unable to keep hydrated. This leads to a buildup of a thick mucus on the outside of the cell. If you pay attention to my little display here, you'll notice that how the CFTR in the first side, on the left side here, shows it pumping out the chloride ions outside into water and mucus outside the cell. Now, this water and mucus is always there, and because of the chloride ions, it helps it keep it thin and loose. But because of the mutation, you can see here on the other side of it, on this part here, without the chloride ions, that mucus becomes a lot thicker, because the protein channel has been mutated, so it doesn't allow proper access of the chloride ions. Now, I've shown you what it does, how it works, But the big question that people will notice the most will be what systems are affected by CF. What body systems or what regulatory systems truly are affected by this mutation on chromosome number 7. There are 3 major systems within the body that are affected because of cystic fibrosis. The first one is the exocrine system. This is the system that works by regulating the body. Things such as perspiration, mucus, saliva, fluids really that work within your body or are released from the body. The exocrine system works mainly to help pump out these things. A good example of this is perspiration, sweat. Because of the mutation, what happens is that cystic fibrosis really causes a person to perspirate a lot more. That's because their bodies, people who have disease, their bodies have a real problem maintaining or holding fluid. Because they perspirate, they sweat a lot because of the disease. And because it's such a high buildup that also occurs because of it improperly pumping out, it also pumps out a large amount of chloride, of salt, out of their bodies. Something that can be noticed about people who have cystic fibrosis is that because of the disease, they've been documented and know that after they sweat, once it dries, they have visible amounts of physical salt on their skin and body. The second system that is affected most heavily by this is the respiratory system. How your body breathes. It affects you. Most place it affects is the lungs. What cystic fibrosis does is because of the lack of chlorine ions, your body builds up a thick mucus in most of these systems being covered here. An example shown here is of how it works in the lungs. The thick mucus essentially builds up on the sides of the lungs itself. This creates an obstruction, makes it much harder for the person to actually breathe. With that said, another downside of this disease is that you breathe in and out, you have little things on the side of your lungs that help push out bacteria that you breathe in. Because of this thick mucus, it cannot do its job well. This results in people getting infections much more frequently than they usually would without it. The final system that's affected the most is the digestive system. A thick mucus that's associated with disease builds up within the pancreas. Now, the pancreas's job is to create enzymes, fluids, and acids for the stomach. But because of this thick mucus, it slows down or stops the production of these enzymes for your stomach. As a result, people who have cystic fibrosis don't properly digest their food or don't digest it well. Because without this aid, because of the clogging of the pancreas's pathways, what happens is that they have a real problem absorbing most proteins, fats, and vitamins into their body. This leads to varying degrees of malnutrition to people who have the disease. Now, the interesting thing I have found about when doing this research was the diagnosis of how this disease is diagnosed. Cystic fibrosis is actually diagnosed at birth, somewhere in the area of at birth to 2 years of age. And it's done through what's called a sweat test. What they essentially do is they put a pad on you that heats up your skin and then causes you to sweat. They then take a sample of that sweat to be tested. This, what they test for really is the chloride levels within the body. If you're within acceptable margins, they know that everything's regulating well. If not, that means that there's a problem, and this is your body's physical response to the problem. I'd like to thank you all for watching my presentation, or maybe just my professor. This here is my citation of the information. Hope you have a good day.